We're discussing the prerequisite skills for the Precalculus mathematics course and mostly trying to remind people of the skills that they may have learned in previous classes that we'll be assuming that we know in this one. We're going to continue with the ones that are sort of iffy about whether you've had it or not. In particular, we'll move on to, I thought a logarithmic question. Maybe I put that in the wrong place. Yes, a logarithmic equation. So the strategy with a logarithmic equation is to get the logarithm by itself on one side, which has already been done here, and then we can use exponentiation to clear out the logs. The natural log is log base e, so if I use exponentiation with a base of e on both sides, in other words, have e to the left-hand side equal e to the right-hand side, then this is an equivalent equation, and it has the advantage that because we have e to the log, then the e and the log are reverses of each other. They're inverses of each other. So e to the log of anything is just that thing. So if we wrote that down as a rule, e to the log of a equals a. And similarly, if it ever came up in the other direction, the natural log of e to the a is a. So the natural log undoes the e undoes the natural log. They're inverses of each other. So therefore, if I can get the exponentiation into the log equation, then I can get the e and the log to undo each other. So on the right-hand side, I just have e to the minus 1, which is just a number. You can use e to the minus 1 on your calculator, and it's 0.3 something. But the point is it's a number. So now I can just solve this the way I normally would. I have a polynomial here, but it's quadratic and I don't have any other terms, and so that gives me the option of just calculating the number on the right and then taking the square root of both sides. So we want to remember the plus and the minus, positive and negative square root. But I can just take the square root of whatever this number is, 1 plus 1 minus 1, that's 1.3 something. And if I take the positive and negative square root, then that'll be the correct answer. I should add here that when the original equation involves logs, we do have potential problems with the domain of this as a function, because remember, I can't compute the log of anything other than a positive number. So it's worth at least a second to think about what this is going to be when I try to plug it back in. But if you do that for both cases, in both the positive and negative case here, when you square the number, you'll get a positive value bigger than 1, and so subtracting 1 will cause no trouble here. But just like when there's fractions in the original equation, it's worth checking answers back in. Same thing with logarithms. It has a domain that's not all real numbers, and so it's possible that this process can give you values that do not actually check back in.